Alright, so here's a little bit of another way of looking at some of the stuff for span. So let's say we're looking back at our idea of that carpet ride problem for Eva and Archer where they're trying to travel. And now they've got three modes of transformation, and now they live in a three-dimensional world. So now V1 will be 111, V2 will be 638, and V3 will be 416. Eva and Archer are only going to be allowed to use each mode of transportation once for a fixed amount of time. We want to find the amounts of time on each mode of transportation respectively needed so they can go on a journey that starts and ends at home, or we need to explain why that's impossible for us to do. Now, what we don't know right now is where Eva and Archer's house is. And to be honest, Dr. Harshia wasn't really sure she wanted this shared with the class anyway. So what could we use to represent the location of their house? Anybody? Anybody? Oh yeah, this is a recorded video. I'm talking to myself. Well, what we could do is, since we don't know, is we can use this as our kind of point where we start with. And so we're going to use this as the origin. So this will be 0, 0, 0 for us. And so now what we want to do is set up an equation for us to use in order to figure out how long we need to be traveling. So we'll use C1, C2, and C3 now instead of using alpha 1, alpha 2, and alpha 3, just to help drive home that we don't really need to use alphas. We could use anything as long as it's carefully chosen. So C1 times 111 plus C2 times 638 plus C3 times 416 is something we want to set equal to 0, 0, 0. Alright, so why C1, C2, and C3? Well, these are going to be our times that we spend on each of these different modes of transportation. And so we want to know how long we need to spend on each of these. So we can use this in order to create an augmented matrix. So what I'm going to recommend is you take a moment to try to figure out what the system of equations is going to be and to determine what our augmented matrix is going to look like. Pause the video, see if you can figure it out, and then I'll show you what the augmented matrix is and what we get when we put it in reduced row echelon form. Alright, still there? Great. So, let's go ahead. The first row will be 1, 6, 4, 0. Our second row will be 1, 3, 1, 0. Our third row will be 1, 8, 6, 0. And when we put this into reduced row echelon form, we'll get 1, 0, negative 2, 0, 0, 1, 1, 0, and 0, 0, 0, 0. Now notice that in this reduced row echelon form, because we have a column that doesn't have a leading 1, C3 is a free variable. And so this gives us C1 equals 2C3, C2 equals negative C3, and C3 equals C3. So this gives us infinitely many solutions. Use a little shortcut here, infinitely many solutions. So we want to just find one possible solution that we could go ahead and use. And note that we don't necessarily have to choose anything crazy, but everything is going to be based on what we choose for C3. So we could say that this is the set of all 2C3, negative C3, C3, such that C3 was an element of the real numbers. Or we could just say that it was C3 times 2, negative 1, 1, where C3 is an element of the real numbers. Well, hey, that's just the span of 2, negative 1, 1. All right, so let's give an example of a solution here. So let's say C3 equals 0. Well, if C3 is 0, then C1 is 0, and C2 is 0. Oh wait, what did we just say? Let's think about this for a second. What we just said was if Eva and Archer want to go on a journey that starts and ends at home, they could travel on each of their different modes of transportation for 0 hours. So really what that means is that if they just don't want to go anywhere, and they'll start at home and they'll end at home. Okay, well that's kind of interesting. But there's an infinite number of ways, as long as we're following along with this, that we could go ahead and start and end in the same place. So let's talk about the thing we actually just did here using our definitions from before. We solved a homogeneous system of equations. Remember, this word homogeneous means that all of our equations were equal to 0. So the other thing we wanted to know is there more than one way for us to make a journey that meets the description above? And the answer is yes. We found an infinite number of solutions. So there are an infinite number of ways that we could go ahead and make this journey. So it's just kind of another example we have of trying to be able to use spans and this idea of spanning sets.